Good morning and welcome back to the Torque Code Madrid from the coffee break. I hope you enjoyed it. First of all, thanks all of you for being here in my talk. But looking at the schedule, you didn't have much choice either, so sorry about that. Secondly, of course, thanks to the Torque Code organization for allowing me to talk about this topic today. We are going to talk about things about offline. But I'm not going to talk from my own eyes. That's why this talk is called Indiana Jones and the Offline Apps. Does the music sound right? All right. As all you know, Indiana Jones is an archaeology professor on the University of Bedford, and on his free time, he's an avid treasure hunter. He travels all over the world looking for relics and treasures to incorporate into their collection and to disallow the Nazis to get their hands on them. This time, his quest is on finding the Holy Grail. The Holy Grail is a legendary artifact that grants eternal life if you get the chance to drink from it. So having done a lot of research and discover where is its location, he flies all over the Pacific Ocean on the direction of Middle East, where the temple is located in the zone of Petra. However, when he arrives there, he finds a bitter truth. The navigation app, which was supposed to bring him to his final destination, is not available. Moreover, the document where he written all the solutions to the riddles and the puzzles that he might find inside the temple is not available either. And even the picture he got of the Grail, it's out of the question, and he needs to know which is the authentic Grail, because if he drinks from a fake one, not only he won't get eternal life, but also will face a very, very horrible and terrible death. So, defeated, but not having surrendered, Dr. Jones comes back home and prepares for how he is going to solve all these questions. He learns of an ancient magic some developers used to have that was... Okay, it will stop eventually. It's because on the rehearsals I was much slower, it seems. All right. So he learns about an ancient magic called offline, which could make the applications work even when they have no network conditions, right? He discovered that any developer wanting to build this kind of magic was able to do so, but only when all the team embraced the culture of offline, the best results could be achieved. Because offline is not only a set of techniques to make your app faster, it's a culture that drives how your product is experienced, right? Being a scholar, the first thing that Dr. Jones thought about is why somebody would like to introduce this to his application. And the first of all was a prophecy that predicted that by 2022, the global consumption of mobile data would increase tenfold. This is an order of magnitude higher. And not only that, in certain regions like Middle East, Africa, or Eastern Europe, that amount would multiply by 12. From an ecological standpoint, he learned that one of the components that drains more battery from the users is actually the screen and the data antenna. And if a developer could save battery by not querying the network continuously on a global scale, the amount of energy that could save could actually make an impact in the world, right? He also interviewed a lot of people, and he heard some testimonials about how people working on the metro, or commuting, or working in basements, or living in rural areas, and even some people on their own houses couldn't get connection if they don't have Wi-Fi, for instance. And this was something that it was not so strange. You didn't have to be on a desert in the middle of Africa or in the middle of the jungle to suffer of these issues. Also, he learned that air is a limited medium, and there were some weird, strange totems called 4G cells. That was what allowed people to connect to their data. And if a lot of people subscribed to a single cell, even if it was connected, let's say, to a 10 gigabit fiber optic behind, the bandwidth available decreased significantly. And not only that, in more extreme situations like concerts or festivals or football matches, of these kind of things, a lot of people subscribing to one of these towers could even provoke a denial of service, not allowing critical calls, like calls to the 911, to pass through because they literally threw down the cell. Also, people who use apps were not engineers. They didn't know about things about HTTP codes, what a timeout was, if there was a service unavailability. The only thing that users wanted were to access the information. And Dr. Jones thought that this was a fair game, right? And finally, there were some groups of strange developers that gathered around lodges called DroidCons that always tried to improve how they made their apps and learn new things that could help the users to feel more integrated with the apps they built. With all that in mind, he was starting to getting a bigger picture on how to build offline applications. And he started unraveling some techniques that the users the developers could use to improve their users' life. The first of all was optimistic experience. Optimistic experience is no more than a small mentality change on how to handle process inside an app. For example, the naive approach we use to manage a process in our app is to allow the user make an action, then you update the UI with a waiting state until the API returns the right result, and then you get the result and again update the UI accordingly, right? But the problem that this has is that the connection is not fast enough, or if there's no connection, the app is going to feel sloppy and it's going to frustrate the user. But if you use an optimistic approach, a small developer could directly apply what's going to be the expected result while he does the work on the background. Even if the connection is slow, the user is going to perceive this app as fast. And you can even save work because you are ignoring that you require a waiting status on your UI because the result is already there. If you were yesterday on Daniel Gallego's talk about architecture and flags, he mentioned that he actually used this optimistic approach with their camera app. They say that when they use the reducer to push a new state to their main application, once the picture is taken, they show a little thumbnail while they still process the picture in the background because it's a costly process, and showing the thumbnail it's not. But even more, we are used to see spinners, and we've been taught that when a spinner is on a screen, it's because it's going to be a little delay time, and we're used to switch tasks and forget what we were doing because we humans are oblivious beings, right? But if you instead of using spinners, you use placeholders like this example. The only thing you have to do is to fill your screen with expected content that is going to appear there, and of course, if your API is not like ultra slow, the feeling that the user is going to receive is that it's something already there. And when the real data arrives, the feeling of progressing is going to be more iterative than showing a spinner and then switching all the content once it's there. The second concept that I wanted to talk about was saliency. Saliency, it's a weird word, but basically means how prominent is something to the user. Usually we talk about errors. With using errors with high saliency, like this one, okay, you are not only pushing an error condition which is not the fault of the user, but neither is your fault. And for instance, in this experience, which is very bad, you try to make the user retry continuously until the situation is resolved. But if you remove a little saliency from the error, not only you are communicating better, but you are saving the user to have a cognitive friction of having to manually retry. In this case, what you are saying is that the content will appear there once the condition is solved. Yes, you are still taking the error to the face of the user, but at least you are implying that you will provide an automated mechanism to solve that issue, and probably even if the user changes tasks with another app, he will be eventually notified. Finally, Telegram makes a really good work out of this, because he hides all the error. Okay, you can only see a small notification there, and the rest of the app work flawlessly. You are supposed to keep, even in no connection situations, you are expected to keep sending messages and pictures and stickers and whatever, and they will get enqueued. And Telegram makes a tacit agreement with the users that those messages will be sent once the connection is regained. Another technique that Mr. Jones learned about was graceful degradation. Graceful degradation is a concept where we are all used to use that in our everyday lives. When the hardware cannot support or the software cannot support certain levels, okay, it degrades their functionality transparently to the user, or as transparent as possible. For example, if the element on the left has not been uploaded to the API yet, and it's, for instance, on a draft, and the right one, it's already there, it's already in the API, it makes no sense to handle edge cases that might arise of trying to like an element which doesn't exist still on the API. So in that regard, a developer can use graceful degradation to provide a covert but effective solution, which is to cut off the kind of source of problems in the future. And finally, one of the most interesting techniques is prefetching. Prefetching is the art of taking advantage of connectivity moments to download more data ahead of time, even if the user is not going to access it in the moment. For instance, a registration process is a very common use case where connectivity is mandatory because you are going to require to create your user. In that moment, for instance, a smart developer could use that guaranteed connectivity moment to download a zero case feed beforehand. So even if he loses connection 1 second after creating his user, he's not going to face an error screen or an empty case saying like, please follow whoever or do whatever, and the experience is going to be improved. And again, you will save time because you don't need to face that use case anymore. So, with all this information, Indiana Jones had clear what was required to build a good offline experiences. A good offline experience was highly optimistical, had low to new saliency in the case of errors, and he was greatly aware of them by hiding them inside of the user experience. But he wanted to delve deeper. From a colleague, a small terror history about developing, which starts like this. Once upon a time, there was a developer who had a great idea for a product. So what he did was a proof of concept on his mobile phone, locally. He saw that there was potential there, and he built an MVP with a remote service in order to allow people to use their product, and it was a success. he had to scale quick of how many users were starting to use his product, and he needed to invest in infrastructure by hiring more servers, using replicated databases, load balancers to hold all the load his system was suffering. But it was still a success. So he hired more people to make clients for their platforms. He had a web client, an iOS client, a Windows client, a macOS client, even a Linux application. Well, it was unheard of, right? And it was still a success. Users could use the product at home on their laptops and then go on access their data on the go by accessing through their iPads or their mobile phones. And he got a company out of this. He was earning a lot of money. And 2 years later, his VP of product said, okay, it's a great idea, but let's make it collaborative. So you can join your friends on doing what the product does, and it's going to be great. So now we have a collaborative, multi-device, multi-server, which was on several data centers around the world. It was such a success that it was unheard of. But then his CTO came to a DroidCon and saw a really weird guy talking about offline, and he said, "Okay, let's do everything offline now." And then in that meeting, the developer stand up and threw himself out of the window. Why? Because you cannot pass from 0 to 60 on a single second using offline. Because if you have a very complex infrastructure, it's going to be a nightmare. So Dr. Jones, which is a very, very smart guy, first of all understood the platform he was working on. Secondly, he understood which feature he was going to allow to be offline, because not every feature can be done offline. For instance, especially features that require real data, in real-time data, are very, very complicated to come by offline. But also, he understood, because he was used to have companions on their adventures, that his team, which was the strengths and the weaknesses of his team in terms of technical prowess, manpower, things that could be a hindering to building an offline application or an offline feature. But he had found out that the key to build an offline architecture was the cache. The cache was the new single source of truth. It was not the server anymore. And this changed everything. But this came with a price, and the price was two problems, because he needed to keep that cache updated as much as possible, but also he needed to bring that single source of truth to the user as fast and as updated as possible. So what he would do with this was to follow a very proven philosophy, which is called the Git way. Pull the changes, then attempt to merge, then push the new modifications, right? And the way to do this was not looking for fleeing IDs that are changed every time you make a copy of the data, but using heavily metadata to follow those changes. For instance, you can use, if it's something, it's a draft, if it's not drafted, if it's been deleted, because as an archaeologist, Dr. Jones is very fond of all documents, books, etc., that allows him to follow the track of what happened along the history. And with his entities was the same. He was interested to know how these entities changed along the time and who changed it in order to understand if there was a problem. If, in the case of revisions, it was not hard at all. He talked with a mathematics colleague on the Bedford University, and he told him about vector clocks and Lamport timestamps, which are algorithms that allows to follow the causality of events on different agents that are usually disconnected, and when this causality is violated. In order to logic differently, it's extremely easy. For instance, take a random use case about changing the avatar. We do this every day. We have an API. We query the API, make the change, right? Then we go to the cache, updates the results, and then we notify the UI that the avatar has changed. This is like the naive, the bread and butter way of doing a use case, right? But if we apply the Git philosophy to this, we can separate that use case on two different cases, which is commit the avatar change by calling the cache and pushing the changes to the server by the API. And once we have these two pieces of the experience, we can combine them to achieve different effects. For instance, we can replicate the classic use case type by commit and then push the changes. And we can build an offline enabled kind of use case by committing the changes on cache. So even if the user has no connection, can still query the cache and see that his changes are there. And instead of directly executing the propagation of the changes, he can use a worker manager with constraints about having maybe Wi-Fi or directly having connection to delay or retry those changes when the connectivity is available. And finally, applying a optimistic UI, what we can do is update the UI on the first moment, and finally send the modifications to the backend of the app, right? Dr. Jones also had a long history of mistakes, and he had an experience on handling errors, right? So he identified three kinds of errors that he didn't have to pay attention about. The first were connectivity problems like socket timeouts, I/O exceptions, 503s, 401s, and this kind of solution usually are solved by retrying or deferring the execution of that part until the connectivity is regained. Maybe the 401 it's a little special because if it's an authentication, if it's because there's an authentication refreshing, you know, because maybe that you have to build a little experience behind that, maybe trying to recover the credentials and ask for a new authentication token or whatever. The case of 404, with exceptions, the best strategy is basically ignore them. If you are trying to follow a user that is no longer there because it's been deleted, you don't need to do anything at all. If you have followed that user and after following him had deleted their account, well, that follow would be lost and nobody would care. And finally, about other kind of 400 errors, they are mostly client-side. So instead of waiting for the backend to do certain validations, you can bring as much of the validation before asking the application to perform work. Dr. Jones is also a smart guy and don't want to work too much. So in that case, the only thing he needs to build a placeholder and real data system is just make a layout and take the advantage of the alias system in Android to multiplex that layout and bring and give two implementations, one for the placeholder and the other for the real item grid, right? Even if he makes changes to the base XML, obviously he's going to maintain his implementations, but he only needs to change the grid once instead of having to do it twice. A key element to keep your single source of truth updated is to push, in the case of multi-device scenario, to push the changes as fast as possible. For instance, if I am working on a web server, on a web application at home on my desktop, and I want to bring my information to my device, it's easier if I talk with the backend and I have some way of pushing directly those information. It can be done with WebSockets, for instance, depends of the of the situation, or directly with a push notification. If the payload is very small, you can feed the entire entity on the payload, on the push payload, which is limited. I remind you of 4 KB. But if the entity is a little bigger, larger, you can just push the increment on the payload. And even if it's the worst case scenario and it's a huge change that is going to modify all the cache, you can use that push notification to trigger a synchronization process on the device. Because eventually, and all this was done in order to push further the conflicts. Because eventually, on a multi-device, multi-agent, which sometimes some of them are not connected, conflicts, it's something that's going to eventually happen. And you have to be clear of it, clear that it's going to happen. But it's not an error cause. It's just a natural conclusion of the topology of the system you are building. And therefore, you can use techniques to treat them, like using diff algorithms or differential synchronization or conflict-free data types, your choice, okay? And solving that conflicts is part of the programmatic resolution, or it's part of the core logic of your app. And finally, as an archaeologist, sorry, Dr. Jones knows that the wheel had already been invented long ago, and he didn't need to invent the wheel anymore. He had frameworks that help him handling offline situations like Work Manager or sync adapters. And in the area of database, there are already databases that have offline capabilities like CouchDB, Realm, or Firebase. And well, with this, having found all the truth about offline applications, he had solved all the challenge and was ready to tackle the next one, which was to retrieve the Grail. But this is a story for another day. But as any story, we have an epilogue, and it's that offline can be implemented a la carte, that you don't have to push all your applications suddenly to offline. You can do small incremental changes with all the techniques we've discussed in order to improve a little by little the experience you provide to your users. Also, understanding your situation is critical. How much people do you have to spare? How much time is going to take with your legacy code? If the feature you want to do makes sense that it's offline or not. And a final thought, as professional developers or professional developers wannabes, it's important that you strive to write the best experience of your app you can think of, and try to reach the goal that the applications you write should work like magic. Here I leave some credits if you want to know more about offline. It's something that came from JavaScript frontends, but it's lately on the game field of applications. And if you want to know how to make this in a more practical way, Juan Carlos is going to be lecturing on how they did this to their Renfe app after this talk. And nothing more. If you have any question for me, I have some barquillos, which is a classical treat for Madrid. And if there's anything I can help you with, any doubt you may have of everything I told you, I will be more than glad to tell you. If you are a shy person, you can ping me at Twitter with @Sephor, and or send me an email and insults at Sephor at gmail.com.
Any questions?
If nobody asks anything, I'm going to leave it there, and first come, first serve.
Hi, I have one question.
I have one question regarding synchronization of data from the server back to the device. So if I delete something from one device and I want that information synced to other device.
Sorry, could you repeat that last part? I didn't get it.
So imagine I have two devices.
Yeah.
On both I'm logged with same account. So on device A, I delete something, image, message, whatever. That's propagated to the backend, and the change is propagated to my another device. So generally, we cannot really do the deletion, but we change the status to delete it. Am I right?
Well, it's safer to do that thing in order to keep a good experience and also to help the user know what has going on. Usually, if you are the only one using your app in different devices, right, you are going to be aware that you did that. But in case of collaborative applications like Drive, for instance, or Dropbox or whatever, if you are a user and you delete a file, another user might not find that file anymore, for instance. So if you only mark it as delete, you can build a recycler bin feature, and you can revert those changes. But if you delete everything forever, you are going to lose all the history, and you are not going to be able to understand what was going on. Not sure if that answers your question.
Yes, but I'm wondering if I really do the deletion on the backend, how could I easily fetch the information that something is deleted if I don't have that something on the backend? Yeah,
in that case, I mean, it's hard to. It's more about what you want to do with the experience when that happens, because, for instance, what I was telling about the 404 errors. If you are a Twitter developer, are you a Twitter developer?
No.
Just in case, because I know there might be some in the room, right? So if I am trying to reply to a post and that post is no longer there, right? Well, it's no longer there; it's gone, and you cannot recover it. So usually, the experience you wanna give might be like from a notification, this item has been deleted, so to speak. I mean, I'm talking hypothetically. Or you can be like more rough and directly make it disappear from a feed, for instance. If you have a cache feed and you receive the notification it was deleted, you remove it from everywhere, and that's all. How you can do it? Like I said, you can push notification, you can use a push or somehow, or it can happen eventually on a periodic synchronization of that feed, so to speak. And if it's gone, it's gone. Sometimes the user might feel a little confused about why things disappeared, but it's something that happens on many social networks and applications, and we are not even aware that that's happening.
Okay, I have one more question. Imagine that I edit one item on two different devices, and I edit it in two different ways. So the question is actually regarding conflict resolution. Do you have any easy solution, like accept the latest one, or it depends on case to case?
Depends on what are the rules of the platform you are doing. You can, I mean, all of them have pros and cons, and obviously all of them have drawbacks, but you can use like the latest change win, the earliest change win, like like pulling the changes, override the changes that other device was doing. But it depends on how you want to manage. In the case of Git, for instance, which is an application we are all used to use. There's a conflict resolution scenario. You have to merge it somehow, or push the push force, or whatever you want to do. In that sense, it's part of how you build that experience. But if the rules are clear, you can let the backend solve it automatically, or maybe you want to open a merge screen. Depends.
Does it mean, sorry, I won't, I don't have any more questions, just, does it mean that business analysts should be more involved in our caching and syncing mechanism than they would usually want?
Yeah, that was my earlier point in the talk, that if you are not doing it like single-handedly, and the people from backend are on the, because it's, like I said, this is not like a technique or a solution, it's a culture, and it drives how you communicate to your user, how the user experiences your app, and if this is something that is product cultural, these are kind of requisites that have to happen on the product definition change. So if you are doing Drive, Google Drive, okay, but so what happens if this situation occurs? And in that sense, the business people or the product stakeholder have to give the rules of what is going to be, and of course you have to communicate them to your users, so they can predict what is going to happen on any situation.
Thank you very much.
My pleasure.
More questions? No? Thank you very much, Saul, for your talk.